Hello friends, welcome to my channel Eccentric Learning. Many videos on various quantitative aptitude topics like percentages, profit and loss, remainders, etc. has already been uploaded. I hope you guys are going through that. If not, some of the videos link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. Today, we are going to start a new topic, cyclicity. In this video, we'll be seeing how we can find the last digit of the higher powers of numbers. And in the next part, we'll be seeing how we can find the last two digits of the higher powers of numbers. So let us start with today's video. Let us start by seeing the last digit of a number. Suppose if I consider this number 1, 2, 3, 4, 5. So the last digit of this number or the unit digit of this number is 5. In a similar way, when I divide this number by 10, in that case, the remainder would be 5. So the last digit of a number is same as the remainder when the number is divided by 10. Now, say if I have this two-digit number, say 53 times of 27. So I want to find here the last digit of the multiplication of 53 times of 27. Now, when you multiply 53 times of 27, this will give us the result as 1431. So the last digit of the multiplication of 53 times of 27 would be 1. Now, instead of multiplying these two-digit numbers completely to find the unit digit, we could have simply multiplied the unit digit to get the last digit of this number. So the last digit of 53 times of 27 would be same as the last digit of 3 times of 7, which will give us 1. In a similar way, say if I have these numbers 22 times of 34 times of 80, and I want to find the unit digit of the product of these numbers. So instead of multiplying these numbers completely to find the unit digit or the last digit, what we can do is we can simply multiply 2 times of 4 times of 8. That is the multiplication of the unit digit of these two-digit numbers. So this will give us the unit digit as 2 4s are 8 and 8 8 is 64. So the unit digit would be 4. In a similar way, say if I'm multiplying these numbers 125 times of 23 times of 276 times of 45, and I want to find the unit digit of the product of these numbers. So again, instead of multiplying these numbers completely, what we can do is we can multiply the unit digits of these numbers. So that would be 5 times of 3 times of 6 times of 5. Now again, if you observe carefully, we have a multiple of 2 in 6 and we have a 5 here. So the product of 2 and 5 will give us a unit digit as 0. So the unit digit of the product of this number would be simply 0. So instead of checking the complete number, what we can do is we can simply check whether the number contains a multiple of 5 and 2. So if it contains a multiple of 5 and 2, then the unit digit will always be 0. Now, let us see what are the last two digits of a number. Let us take the same example, 1, 2, 3, 4, 5. So here, the last two digits of the number would be simply 4, 5. And this last two digits of this number would be same as when this number would be divided by 100. Because 1, 2, 3, 4, 5 when divided by 100, the remainder would be 45. So the last two digit of a number would be same as the remainder when a number would be divided by 100. Now let us see what would be the last two digit of 123 times of 160. Well, again, if you multiply these numbers completely, then this would be 14268. So the last two digits would be simply 68. Now, instead of multiplying these two numbers completely to find the last two digits, we could have simply multiplied the last two digits of 123, which is 23, times of the last two digits of 116, which is 16. Because 23 times of 16 would be 368. which gives us the same last two digits as this one. We can also think this multiplication in this way. 123 is 100 plus 23 and 116 is 100 plus 16. So when we expand this, this would be 100 into 100, that would be 10,000 plus 23 times of 100, that would be 2300 plus 16 times of 100, that would be 1600 plus 23 times of 16. Now all these terms have the last two digits as 00. So the addition of these three numbers will give us the two digits as 00. So the last two digits of the multiplication of 123 times of 116 we'll be getting simply by 23 times of 16. So the last two digits of 123 times of 116 would simply be the last two digits of 23 times of 16, which would be 68. So whenever we need to find the last two digits of a number, we need to focus on the last two digits of each number to get the last two digits of the final number. Now let us see the last digit of 132 raised to power 75. So 132 raised to power 75 would be 132 times of 132 times of 132 till 75 times. So the last digit of this number would be same as the last digit of 2 raised to power 75. Now 2 raised to power 1 will give us the last digit as 2. 2 raised to power 2 will give us the last digit as 4. 2 raised to power 3 will give us the last digit as 8. 2 raised to power 4 will give us the last digit as 6, because 2 raised to power 4 is 16. In a similar way, 2 raised to power 5 will give us the last digit as 2. 2 raised to power 6 will give us the last digit as 4. 2 raised to power 7 will give us the last digit as 8. 2 raised to power 8 will give us the last digit as 6, and so on. So you can see here the last digit of the higher powers of 2 follows a pattern and it repeats after every fourth power. So the last digit of 2 raised to power 75 would be same as the last digit of 2 raised to power 3. Why? Because when we divide 75 by 4, the remainder is 3, and higher powers of 2 follows a cyclicity of 4, that is 2, 4, 8, 6, 2, 4, 8, 6, and so on. So the last digit of 2 raised to power 75 would be same as the last digit of 2 raised to power 3, which would be 8. In a similar way, if I want to find the last digit of 2 raised to power 242, say, again, here we need to find the last digit of the higher powers of 2, and we know the higher powers of 2 has a cyclicity of 4. So 242 divided by 4 will give us a remainder of 2. So the last digit of 2 raised to power 242 would be same as the last digit of 2 raised to power 2, which would be 4. In a similar way, if we go for the higher powers of 3, we will notice that it also follows a cyclicity of 4. Let us see how. 3 raised to power 1 will give us the unit digit as 3. 3 raised to power 2 will give us a unit digit of 9. 3 raised to power 3 will give us a unit digit of 7. 3 raised to power 4 will give us a unit digit of 1. Now 3 raised to power 5 will give us a unit digit of 3. 3 raised to power 6 will give us a unit digit of 9. 3 raised to power 7 will give us a unit digit of 7. 3 raised to power 8 will give us a unit digit of 1, and so on. So here also we can see that it also follows a cyclicity of 4. In a similar way, higher powers of 7 and 8 also follows a cyclicity of 4. Now, for example, say if I want to find the last digit of 127 raised to power 279, say. So the last digit of 127 raised to power 279 would be same as the last digit of 7 raised to power 279. And we know that 7 also has a cyclicity of 4. So when we divide 279 by 4, the remainder would be 3. So the last digit of 7 raised to power 279 will also be equal to the last digit of 7 raised to power 3. And 7 raised to power 3 is 343. So the last digit would be 3. Also, let us take one example for the higher powers of 8. Say if I take this number 438 raised to power 480. Say I want to find the last digit of this number. So again, the last digit of 438 raised to power 480 would be same as the last digit of 8 raised to power 480. And we know that the higher powers of 8 also has a cyclicity of 4. Now 480 is completely divisible by 4. So the last digit of 8 raised to power 480 would be same as the last digit of 8 raised to power 4, which is same as 8 square times of 8 square. 8 square is 64. So the last digit would be 4. And here also the last digit would be 4. So this will give us the last digit as 6. So the higher powers of numbers ending with 2, 3, 7 or 8 has a cyclicity of 4. So we can simply apply this to find the last digit. Now let us see the last digit of the higher powers of numbers ending with 4 and 9. So let us start with the last digit of a number ending with 4. We know 4 raised to power 1 will give us the unit digit as 4. 4 square will give us the unit digit as 6. 4 cube will give us the unit digit as 6 times of 4, that is 4 again. 4 raised to power 4 will give us the unit digit as 4 times of 4, that is 6. 4 raised to power 5 will give us the unit digit as 6 times of 4, that is 4 again. And 4 raised to power 6 will give us the unit digit as 4 times of 4, which is 6 again, and so on. So in case of 4, we can see that it has a cyclicity of 2, and 4 raised to some odd power gives us the unit digit as 4, and 4 raised to some even power will give us the unit digit as 6. And the last digit of 164 raised to power 234 would be same as the last digit of 4 raised to power 234. And since 4 has a cyclicity of 2 and 4 raised to some odd power gives us the unit digit as 4, and 4 raised to some even power gives us the unit digit of 6. And here 234 is an even number. So the last digit of 4 raised to power 234 would be simply 6. In a similar way, the last digit of 319 raised to power 485 would be same as the last digit of 9 raised to power 485. And just like 4, the higher powers of 9 also has a cyclicity of 2. Let us see how. 9 raised to power 1 gives us the last digit as 9. 9 square will give us the last digit as 1. 9 cube will give us the last digit as 9. 9 raised to power 4 will give us the last digit as 1, and so on. So it also follows a cyclicity of 2, 9, 1, 9, 1, 9, 1, and so on. And 9 raised to some odd power gives us the unit digit as 9, and 9 raised to some even power will give us the unit digit as 1. So 9 raised to power 485 will give us the unit digit as 9. So the higher powers of numbers ending with 4 and 9 has a cyclicity of 2. So we can simply apply this to find the last digit. Now the higher powers of numbers ending with 0, 1, 5, and 6 has a cyclicity of 1. So what does this mean? This simply means that the higher powers of numbers ending with 0, 1, 5, and 6 will have the unit digit as 0, 1, 5, and 6 respectively. For example, say if I want to find the last digit of 416 raised to power, say 255. Now the last digit of 416 raised to power 255 would be same as the last digit of 6 raised to power 255. Now 6 raised to power 1 gives us the last digit as 6. 6 square gives us the last digit as 6 times of 6, which is 36, that is 6 again. 6 cube will again gives us the last digit as 6, and so on. So the higher power of 6 will give us the unit digit or the last digit as 6. So 6 raised to power 255 will also give us the last digit as 6. In a similar way, the higher powers of numbers ending with 0, 1 and 5 will also have a cyclicity of 1. So they will give the unit digit as 0, 1 and 5 respectively. Now, if we summarize this, we can say that if a number ends in 0, 1, 5 or 6, in that case, it will have a cyclicity of 1. That is, the last digit of any power will remain the same. In a similar way, if a number ends in 4 or 9, in that case, it will have a cyclicity of 2. In case of 4, the odd power will give us the last digit as 4 and the even power will give us the last digit as 6. In case of 9, the odd power will give us the last digit as 9 and the even power will give us the last digit as 1. And if a number ends in 2, 3, 7 or 8, then the higher powers will have a cyclicity of 4. In such cases, we will divide the power by 4 and we will check the remainders. For remainders 1, 2, 3 or 0, we will raise the last digit to 1, 2, 3 or 4 and we will note the resultant last digit. Now, let us find the last digit of these numbers. I would suggest you to find the last digit of these numbers from your end first and then to look at the solution. The first is 24 times of 65 times of 46 times of 77. So here, if you observe carefully, it contains a multiple of 2 and it contains a multiple of 5. So directly we can say that the last digit would be 0. For the second case, we need to find the last digit of 623 raised to power 623. So its last digit would be same as 3 raised to power 623. And we know that 3 has a cyclicity of 4. So 623 divided by 4 will give us a remainder of 3. So its last digit would be same as 3 raised to power 3, which will give us as 7. Now, let us see the third one. We need to find the last digit of 416 raised to power 78. So the last digit of this would be same as the last digit of 6 raised to power 78. And we know that the higher powers of 6 has a cyclicity of 1. So the last digit of 6 raised to power 78 will be 6. Let us see the fourth one now. 127 raised to power 43 raised to power 4. So this can be written as 127 to the power 43 times of 4, which would be 172. So the last digit of 127 raised to power 172 would be same as 7 raised to power 172. And we know 7 has a cyclicity of 4. So when 172 is divided by 4, the remainder would be 0. So the last digit of 7 raised to power 172 would be same as the last digit of 7 raised to power 4, which would be 1. Now, let us find the last digit of the summation of these two numbers. So the first number here is 738 raised to power 738 and the second number is 829 raised to power 829, and we need to find the last digit of the summation of these two numbers. We know the last digit of 738 raised to power 738 would be the same as the last digit of 8 raised to power 738, and the last digit of 829 raised to power 829 would be same as the last digit of 9 raised to power 829. Now, the higher powers of 8 has a cyclicity of 4, and when 738 is divided by 4, the remainder is 2. So the last digit of 8 raised to power 738 would be same as the last digit of 8 square, which would be 4. And the higher powers of 9 has a cyclicity of 2, and we know that 9 raised to some odd power will give us the unit digit as 9, and 9 raised to some even power will give us the unit digit as 1. Here, the power is odd, so the last digit of 9 raised to power 829 would be simply 9. So this number has the last digit as 4 and this number has the last digit as 9. So the last digit of the summation of these two numbers would be 4 plus 9, that would be 3. So to find the last digit in such cases, we'll find the last digit of all the numbers individually, and then we will add them up to get the resultant last digit. So that's it for today's video, in which we have seen how we can find the last digit of the higher powers of numbers. And in the next video, we'll be seeing how we can find the last two digits of the higher powers of numbers. So I hope you have learned something in today's video. But if you have any confusion, you can watch the video again. And still, if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.